Hello and good day, geometry. We're going over PO19, which is an extension of CO18. In CO18, we learned about what corresponding angles are: alternate interior, alternate exterior, consecutive interior. We focus on identifying the locations. In PO19, we actually start using them to look at relationships within parallel lines. So the key to this objective is we're working with parallel lines. Of course, parallel lines are lines that will never intersect. Okay. The symbol for parallel lines, like we briefly mentioned past couple days, are these little triangles, or sometimes you'll see them as like arrows. Okay. That's the symbol to show parallelability. All right. Questions on that? Okay. So parallel lines. Lines that never intersect. You should already probably know that definition, but there it is for you. Okay, and as it turns out, some pretty neat things happen when a transversal intersects two parallel lines. Corresponding angles, right? That same location, different vertex. So an example of corresponding angles, okay, if we've got our two parallel lines with transversal coming through them, the corresponding angles, an example would be those two angles there, are congruent. That's the relationship. Alternate interior angles are also congruent. So again, if we have parallel lines, transversal, connecting them or intersecting them, alternate interior, one there and one there. Opposite sides of the transversal, in between or inside the parallel lines, those are congruent as well. Okay. Alternate exterior angles are also congruent. Right? Outside the parallel lines, opposite sides of the transversal, they are congruent as well. The only one that's different is this fourth one. Those consecutive interior angles are not congruent, they're supplementary. Okay, which means what? Supplementary means what, Drake? And to be 180 degrees. Okay? So you've got the parallel lines, you got the transversal coming through. An example of consecutive interior angles might be these two here. So this one is 100. This one here would be 80. Okay, they're not congruent. They're supplementary. And these relationships only exist when you have parallel lines. Okay, you must know that the lines are parallel in order to know that these relationships exist. Okay? Questions on any of that? Because once you know this, your toolbox just like doubled in size. Because what you're able to solve for now, what you're able to determine knowing this is a lot of stuff. It says find the measure of angle 1 and angle 2. Explain using one of the relationships above. Are these lines parallel? Mm-hmm. Yes. We see the little triangles, little arrows up there. Okay, they are parallel. Which angle measure would you like to give me first? What do you want to start with, Will?
Angle 1.
Sure. What is the measure of angle 1? 54. Okay. And we didn't use one of the relationships of above to show that, right? Because angle 1 is at the same vertex as our given angle. How do we know that angle 1 is also 54? What other tool in your toolbox can you use, Joe? Vertical angles. Good. Okay. The vertical angles theorem, or just VA, or vertical angles, or whatever you want to write. But now that we know that angle 1 is 54, we actually have two different options here to know what angle 2 is. What's the measure of angle 2? Take a look at what we know. We know that our given angle is 54. Look at the relationship of angle 2 with that given angle. We also now know that angle 1 is 54. Look at the relationship of angle 2 and angle 1. What are some options here? Will, you have your hand up? No? Joe? 54. Yeah, angle 2 is 54 as well. Why, Joe?
Because it's congruent to 1.
Why? What? You're absolutely right. What relationship tells us that?
It's parallel with the other line, and it's opposite.
So corresponding alternate interior, alternate exterior, which one of those three? Alternate interior, yes. Okay. Going from angle 1, because of alternate interior angles, we know that angle 2 also has to be 54 degrees. If we didn't know angle 1, what's another way that we could prove that angle 2 is 54 degrees?
Another corresponding.
It corresponds with our given angle, right? You see what I mean? That your toolbox just like doubled, okay? There's now multiple ways to get the information that we want to find. If we didn't find angle 1 first, we could get to angle 2 with corresponding angles. But finding angle 1 first, because of vertical angles, it opens up another avenue. Angle 1 and angle 2 are congruent because of alternate interior angles. All right? Let's look at the next one. I'm going to have to write a little smaller, I believe, here. Okay? Angle 1 and angle 2. What do you see? What can you determine? Drake?
Angle 2 and 95 degrees are alternate interior.
Okay. So the relationship between angle 2 and our given angle is their alternate interior angles, right? Inside the parallel lines, opposite sides of the transversal. That relationship is they are congruent. So angle 2 has got to be 95 degrees because of alternate interior angles. Now that we've determined that, give me 2 ways that we can determine angle 1.
One way would probably be that the 95 is corresponding to the 1.
So angles at the same vertex can't correspond with each other, right? Corresponding angles, same location, different vertex. So we can't use that one to get angle 1. Will?
Angle 1 is consecutive interior angles to 95.
Okay, so the relationship between our given angle and angle 1, they're consecutive interior inside the parallel lines with the same side of the transversal, which means they're not congruent, they are supplementary. So if our given angle is 95, angle 1 has to be 85. And we got that with consecutive interior angles. What's another way we could prove that angle 1 is 85 degrees? The first way was looking at the relationship between these 2 angles, right? We know that angle 2 is 95, so what's the relationship between angle 1 and angle 2 that we could use? Right?
Supplementary.
They are supplementary because they are a
Consecutive interior.
they have to be at different vertices. We did that one for that one. Well,
Linear pair.
LPP, yeah. Okay. The other one we could use, angle 1 and angle 2 are a linear pair, right? They make a straight line at the same vertex, so that also shows that angle 1 is supplementary to 95, making it 85. Maybe I haven't mentioned before how important it is to know all these theorems and postulates and terms in that. Okay, we're just getting more of them, right? And so if you've been keeping up, which many of you have, that's a good thing. If you haven't, it's never too late to start. But knowing these is important. The last one here. Our given angle is 135 degrees. We see the lines are parallel. It's got the arrows, got the markers there. What's the measure of angle 1 or angle 2? If you can get that one directly. Drew.
Angle 1 would be 135 degrees because of
Go ahead.
corresponding angles.
Awesome. Very good. Yeah. Okay. The relationship between 135, our given angle, and angle 1, they correspond, right? Same location, that upper right section, different vertex. Means they're congruent. Okay. So this is 135 here. And what's the measure of angle 2? What's the measure of angle 2? Blake?
45.
And how do you know that?
Consecutive interior.
Not consecutive interior angles, because angle 2 is outside the parallel lines, so we can't use any of the interior ones. We can't use alternate exterior, because alternate exterior would be outside the parallel lines, which you don't have any angles on the outside of the other one. Drake?
also be corresponding?
Not corresponding because, I mean, and this is where, you know how I always said you can't look at it and assume something? You know, but we can clearly see here that angle 2 is not an obtuse angle. Angle 2 is definitely acute. And so it can be the same measure as that 135-degree angle there. And it's not in the same location, right? Angle 2 is that bottom right, whereas 135 is the upper right. Well, linear pair again, okay? Two angles that make a line are supplementary. They make a linear pair, and that's what we would use. Okay? So success in PO19 is being able to recognize those relationships and knowing what they mean. All right? Questions on this? Okay. Same type of thing, but now tying in a little bit of algebra, perhaps. It says find the values of x and y. The first one here is very similar to the three we did up above. It's pretty straightforward. Rather than finding angle 1 or angle 2, you're solving for angle x and angle y. But let's look at the second one. What do we know? What relationships do you see here? Gino?
48 equals 5x minus 17.
Okay, and how do you know that these two angles, the 48 here and the 5x minus 17, how do you know they're congruent?
Alternate interior.
Excellent. Okay, look at their position. Inside the parallel lines, alternate or opposite sides of the transversal, that relationship shows us that they are congruent. And being congruent, we know that their measures are equal. So to solve for x, that's the equation that you would set up. And then you go to town. And then easily to check your answer, right? Whatever value you get for x, plug it into your equation, you know it should equal 48. If it doesn't, you know it's wrong. So it's all got to fit together here. What about angle y? What can we use to get angle y here? Anyone we haven't heard from yet today, perhaps? A new contributor? Join in on the fun. All right, Nathan?
Consecutive interior.
Consecutive interior angles, right? Same side of that transversal inside the parallel lines. What is the relationship for consecutive interior angles? Yeah?
Supplementary.
Supplementary. So angle y would have to be, well,
132.
132. Okay. Questions on that? Write your two equations you can solve for the last one there. That will allow you to solve for x and solve for y. What's the relationship of that given angle 58 and our 2x? And then what's the relationship to the angle 58 and the 2y? And while you do that, I'm going to see what I'm going to give you for homework, because that's pretty much all there is to it.
5 questions?
I say we do it.
Only 3.
Well, let's see here.
He's a teacher.
Yeah, you're
Better than me.
You can overrule.
No, I
Oh, well, the president of the school, you can overrule a teacher.
Are you talking about overthrowing the
There's
government
talk.
to
No,
ban?
I don't have enough power to.
Do it, you're president.
And it's your birthday.
Yeah, it's your birthday, like, do something.
No, wait.
No.
What section is it even from? Oh, 3. I was way off. I was in chapter 2 still.
No, you can be that deserves no. That deserves no. It's almost Joey's like birthday, so I just
Okay. What equation? Well, I struggled to find your homework here. What equation did you come up with for either x or y? What relationships, Drake?
For x, 2x plus 58 equals 180.
And how do you know that 2x plus 58 has to equal 180?
So
Linear pair. Okay, therefore they are supplementary. They make a straight line. That's got to be 180 degrees. How about for y? What would you set up to solve for y? Which is solve for y? Will?
2y equals 58.
And what relationship tells you that those two angles are congruent?
Corresponding.
Corresponding. Same location, different vertex, both in that upper right section. Okay? Which is a lot easier to see now, that same location, now that we're dealing with parallel lines, because they look the same, right? In CO18, it was kind of wonky the way the lines were all twisted and turned. But here it's much easier to see that. So hopefully that does help. For homework, I found what I want. I would like you on page 157.
No,
He said that.
he said that.
No president of any school would turn down the opportunity for more education, right?
Wow.
No.
They're putting
Right?
words in my
No,
mouth.
Don't
there's
you
already
want
practice
the
on- there's already
students of your
practice
math
on
class to
that.
be the best they can be?
You don't believe that we're the best we can be?
Oh, we need to practice.
9 through 19.
Yeah. The TG test.
9 through
Exactly.
19.
The TG, yeah. Well, you're not going to see a ton of geometry on that one coming up this weekend anyway.
Yeah.
And that might be it. Is that all I want to give you?
Yes, that's
It's
not.
Blake's birthday.
That is oh my god, that is a lot. That's like the 20th time you guys made that excuse today.
And then on page 160,
I don't care.
oh, page 160,
Oh.
1 through
I
7.
feel you.
That is it.
I got
They're all short answer.
I
Not a
feel
whole lot
you.
to them.
Nothing.
Blake. Okay, you have 5 minutes to work on it now. Do tomorrow. Let's play the number game. That was fun. That's how I'm at.
It was a book.